welcome to this webinar about cybersecurity in solar PV sites. So this webinar is organized by Suntrack by P4Q in collaboration with our partner from Security. My name is Noemi Perez. I'm the Commercial Director at P4Q. And well, as you know, cybersecurity, it's a topic gaining more and more importance every day for our business. So today we would like to share with you our experience and knowledge on this topic. So we really hope that you find this information interesting and useful for your activity as well. So today I have here with me my colleagues to speak about this topic. So I have here Edorta Echave, who is ICS Security Architect at Security. Also here with me, David Monroy, who is a Commissioning Technical Manager at Suntrack Services, and also my colleague Sandra Morales, who is Product Manager at Suntrack by P4Q. But before we go into the technical details, just allow me to say a few words about our company. So we at Suntrack are the largest solar tracking control system vendor. Obviously, we are focused on maximizing the production of solar sites, and we do that through a very extensive product and service ecosystem. Today, we manage more than 34 different types or variants of controllers, of TCUs. So this means that we are able to fit almost any possible condition that we can find in a solar site. We supply these products from 3 different locations worldwide, and we also are very close to the operations of our customers with 6 different service centers. Along the 20 years we have been working in this industry, we have already installed more than 40 gigawatts already. So in terms of devices, we are talking about 800,000 TCUs, and we are present in more than 1,700 solar sites. This company started on 1999, so this year we will celebrate our 25th anniversary. We are very, very proud of that. Solar business arrived to us a bit later, but this is to say that we really have a very strong background on industrial manufacturing, electronic industrial manufacturing, and also on hardware and software design. So today we are a one-stop company, from the first idea of the product to the final service of or after-sales support. As I mentioned, it is not only the product, it is also the services we offer, and we have portal where we communicate with our customers, smart monitoring capabilities, and for sure advanced algorithms as well. So altogether offers a complete solution for customers and for the PV solar sites. Here you can see that we are active worldwide. This chart shows our biggest market attending to where we have the biggest installed park already. So you see that if we count together both North and South America, the Americas is our biggest market, then followed by Europe, and finally by Asia or the Middle East. In consequence, we have 3 production plants to serve these markets. We have our headquarters here in the north of Spain, in Bilbao. Then we have the production plant in the USA, in Albuquerque, as well as a production plant in Kunshan, in China. All these 3 plants count on their own service center. And additionally, we have service centers in Mexico, also in Brazil, and in Chile. Altogether, we are able to produce 500 megawatts every week. And with all these capacities, we are also very proud to say that this year we will achieve our 1 million TCU. So that's a bit of experience in the market. So we hope, as I mentioned before, that we are able to share with you what we know about cybersecurity, or what we have learned during this time. So, and now, Jess, let's move to the technical side of the webinar. So I will let Edorta put some context about cybersecurity, and also to clarify some main concepts on the topic.
Hello, everyone. It's necessary to express my gratitude in name of Security and myself to invite us to talk about industrial cybersecurity, to talk about cybersecurity in photovoltaic power plants. My name is Edorta Echave, and I represent Security. Cybersecurity is a specialized cybersecurity firm. It's located in Madrid. Our headquarters are there. And we have a branch office in the north of Spain, the Basque Country area. We are 100% a Spanish company, as I said, and our approach is talking about 360 security to protect our customers in IT environments and in OT environments. Our missions is to help the companies to reduce the risk, to implement the different technologies in the IT environment and the OT environment. We have 2 advanced security operation centers. The main is in Madrid, and the second one is located in the Basque Country. And security is part of LKS. It's a cooperative firm and belongs to Mondragon Corporation Group. So first of all, I would like to talk about some definitions, and it's necessary to understand the different risks that we assume when interconnect the different technologies, the different devices in power plants or photovoltaic power plants. First of all, we have to understand that a vulnerability is a weakness or weaknesses in information and operational systems, system procedures, controls, or implementation that can be exploited by a third source. That is internal, external, and known or unknown actors. Understanding this is the source of vulnerabilities and predisposing conditions can help identify optimal mitigation strategies, because we have different approaches to protect our photovoltaic power plants. The first step is to make inventory, to collect and gather information about systems, devices, or different components that we can find in photovoltaic power plants. But this is enough for us, because we have to keep in mind and collect information about communication channels, because once we connect a device to a data network, we are increasing our attack surface. And finally, we have to keep in mind to define policy and procedures that said or get information about the people, how to act in case that there are a cybersecurity incidents. So a vulnerability can be a potential risk that a third source could exploit by a definite attack vector, and the consequence is a cybersecurity incident. But we cannot confuse consequence and impact. It's not the same. It's not the same meaning. Consequence is an operational issue, and the impact we can measure in order to economical or financial consequences. So what happens when we have or suffer a cybersecurity incident? What kind of cybersecurity incidents can find in a photovoltaic power plant? For example, physical damage, sabotage. We can lose visibility, we can lose control if somebody or something can get access to a different devices and try to modify some parameters, variables, or different kind of characteristics or features that can modify the behavior of the devices of components involved in the productions of energy. We can find denial of services, okay? We can suffer electric outage. And finally, we can find tailored malware for electric grid operations. The main example is black energy malware. So the next step is to talk about the technology, because it's very different when we want to protect or reduce the risk. If we are in a factory, if we are in a shop floor, for example, now today we are not talking about machines, tool machines, assembly lines, or other kind of OT technology. So in a power plant, we can find solar inverters, methane station, power plant controllers, managed network devices such as switches or routers, local SCADA servers, time servers, real-time automation controllers, and finally, protection and control equipment, among others. So our approach to protect photovoltaic power plants is very different than the approach to protect industrial environments based on plants or factories. So finally, we have to talk about the different strategies that we have to follow. Okay, so the first one is to talk about the defense and dev strategy. So this is a strategy based on implement different security protection layers, and the first one is to define a clear and effective policies and procedures. Then the second one is physical security measures that nobody can get access to the utility or installation. Then we have to apply network security measures to control the traffic or how the different devices can exchange information between them. The next one is security applied to a device, following the software, and finally the component. Okay. So the second one approach, the second one strategy is zero trust. We cannot trust in devices, in networks, in data, or maybe in people. Okay, we can to protect, we can to define, to have to identify the different risks in these main four topics. That is, and finally, we have to apply security by design. Okay, in the first step, we have to include the security on people, technology, and procedures. And everything is based to a correct cybersecurity management system. Okay, we have to manage the different strategies, the different devices, because if we don't do this, be sure that in the near futures we can suffer a cyber attack. So next one, I'm going to move the laptop to my colleague David.
So, thank you, Dorta, for this introduction. Okay, so in this increasingly interconnected world, cybersecurity stands as a fundamental pillar in safeguarding data and preserving system integrity. In this context, we are pleased to announce that we have improved our system. This cutting solution is designed to enhance the cybersecurity of the devices. Focused on proactive prevention, Suntrack offers advanced tools and controls that ensure the confidentiality, integrity, and availability of critical information. As our colleague Dorta has explained so well, we will need to protect all the equipments supplied to our customers. In this aspect, we will need to classify our devices so we can choose the correct applying controls. One of the classifications we need to do is knowing whether we are talking about an IT or OT device. An IT device is a physical equipment used in information technology environments. Those devices are thought to ensure data processing, communication, and data management. Their primary purpose involves the efficient handling of data, facilitating an organized and secure flow information. In addition to data management, these devices act as fundamental tools for communication. On the other hand, it is talk about OT devices, which are equipments used in operational technology. Devices typically designed and dedicated to automate, control, and monitor processes in the industry. Their primary purpose involves the control of the operations for different industrial applications. In addition to operational control, these devices need connectivity to receive orders and readings. Another key aspect is their ability to perform advanced computational tasks. While there is some overlap between OT and IT devices, they serve different purposes within their respective domains. As summary, OT devices are dedicated to the control and monitoring of physical processes, while IT devices are primarily used for information processing and communication. However, with the increasing integration of OT and IT systems, there may be instances where devices serve dual purpose or bridge the gap between these two domains. I mean, the IT need the data given from the OT devices. Here we can see a schematic of our on-site system. For Suntrack, the main physical device is the NCU, what we call Network Control Unit, which will have capabilities to manage up to 200 trackers. Then the trackers will have the TCUs, what we call Tracker Control Unit, could move. They will be able to move the trackers following the sun, avoiding the shadows in the sunrise and sunset when the sun is at lower angles, what is called backtracking. Or even the SCADAs or any wind sensor will be able also to manage the position of these TCUs. Finally, as Suntrack by B4Q, we've got the RSUs, the remote sensor units, where anemometers, snow sensors, or piezometers, amongst others, could be connected. In almost all the site networks, there already exist a lot of devices such as SCADAs. In this case, the SCADAs will be able to manage or command the NCUs. Then it will be broadcasting this information to the final devices, to the TCUs. We can also find other NCUs and some other computers connected to the same networks and other kind of devices. In this case, we will need also a PC data logger in order to get data from our devices and carry out maintenance. Okay, so once we have seen a succinct summary of the system, in this following slide, we have made this division, this IT and OT division. In this case, you can observe that all the electronics manufactured by P4Q belongs to the OT schema, while the cloud system and the data logger fits in the IT system. The main target of the data logger is to get the data from the on-site sensors and post it in the cloud, taking into account that the communication needs to be secure between both extremes. As I have said before, the NCU belongs or will be connected to a network. This means that we will need to ensure that our system is secure, but the owner of the network will also need to acquire some commitments. We have prepared now a new hardened NCU model focused in cybersecurity. In this case, we have put some of the actions that we have taken, such as enable the encryption of the TCP. The PC inside the NCU is the unique device connected to the network, to the site network, and it is working as a firewall also. This IPC has some new features, which are the secure boot, one-time programmable fuse, disk encryption, firewall configuration. We will communicate with SSH through certificates. Also, it is possible to connect to the NCU through HTTPS, and we have applied a new password policy, as you can see in your screens. All the physical schema shown above, we have tried to show the secure communication schema that we have now. From bottom to top, we have the end devices, the TCUs and RSUs, which will communicate with their associated NCU, as it is shown in the picture. Additionally, this master will be able to communicate when configured with other devices like itself to share, in example, weather information. On the other hand, we have the SCADA and the site PC, which will be capable of communicate via Modbus or HTTPS. Furthermore, the site PC using Suntrack tools will securely communicate with the NCU and the end devices. To achieve this, the site PC will require access to our cloud services, either through a VPN site-to-site or any agreed upon mechanism. Lastly, we have the mobile application that will connect via Bluetooth to the devices once you have logged in our system. All the things that we have talked about have moved us also to improve our configuration in our clouds. On the left, we've got the universal login of all our systems, and on the right hand, you will be able to find the data lake and the data encryption that we've got in the cloud. Inside the universal login, you can find some of the advantages of using them, such as secure authentication, which will allow us multi-factor enabling, encryption of sensible data, and brute force protection. There are some more, but you can read in the slide. On the other hand, related to the data lake, it will give us benefits such as the encryption of the storage data. The transit of the data will also be encrypted, and monitoring alerts in real time could be configured in the system. And this dialogue continues to be enriched by diverse perspective. It's an honor to now pass the floor to my colleague, Sandra, who will be able to share valuable information regarding regulations.
Thank you, David. As a global company, we prepare our product to considering the requirements of main market where we are. And in this case, for the main regulation also. So the IEC and the NERD have been our guidelines for the Hardened NCU. As a digitalization of industrial sector is accelerating, also the cybersecurity risks for industrial control system. In recent years, have seen an exponential rise in cyber attack on industrial automation and control system running critical infrastructure. So cyber integrity of industrial environment has become a top priority for all the companies. This new challenge that have led the European Union to develop a new policy that guarantee the security of the product. And in this frame, all the manufacturers need to move on. The standard that regulates cybersecurity is the well-known IEC 62443 that is giving the guidelines and the best practices for the industrial product. It's supposed that the European Cyber Resilience Act regulation will come in force this year. So it's supposed that it's going to be mandatory for product manufacturers. So Suntrack started giving steps to fulfill the requirements, and it's for this reason that P4Q worked in the last year in a new hardened system, and also started diving in the IEC 62443.1. NERD is a set of security standards that were developed for protect the critical infrastructure in the North America power grid. These standards were created to ensure the electric power companies and other entities that operate this critical infrastructure, not including only the owners, also the operators and users of any part of this system, and take appropriate measures to protect against cyber attacks and other types of security vulnerabilities. Suntrack, in this way, has set the standard that you can see on the screen and has made the necessary changes, some of them that has been explained by my workmate David, to comply with the NERD, like a password policy, use of firewalls, or make contingency plans. So the aim of Suntrack during the last year was to establish appropriate security controls in our system, to give security to the solar side, that are the ones that are going to be audited by the NERSIP. External analysis has been essential for us to identify the potential vulnerabilities and to strengthen defenses and maintain the confidentiality and the integrity of our product. So we request a pen testing, in this case to security. This security audit carried out involve an ethical hacking process, which include several testing procedures and multiple tools like Nmap, Nessus, for example, amongst others, with the objective of evaluating the security of our system. In this test, have been testing services like a web service, Modbus, SSH, or connection port, communication port. The first scenario was tested like a black box, where the auditor was remote and unable to interact with the system, with the NCU. And the other two ways to test was as a gray box type, in this case with access to the NCU and with a basic knowledge related to the system configuration. So the first, without any physical access and attacking to the Zigbee communication. Then with access via Ethernet to the different elements that are in the NCU. And the last one, with physical access by COM cable. You can see here how the vulnerabilities are classified. So as a summary of our pen testing, we can say that we are satisfied with the result. And the main point is that no vulnerabilities has been detected in the Zigbee communication, as is Zigbee encrypted, and no vulnerabilities in the access to the PC. It's true that some low and medium vulnerabilities have been detected, but with no relevant impact for our system. Nevertheless, we are trying to mitigate them. So we can conclude that we have a hardened NCU. As you can imagine, the cybersecurity is a continuous process that will carry out changes not only in the product itself, but also in the way that we are going to maintain the product. So with this, I think that we can say that we have concluded our presentations.
Okay, so thank you. I think that we are already running a bit out of the forecasted time for this webinar. So again, thanks a lot for joining us today, and stay connected to Suntrack because we will launch more webinars this year. Thank you.
Thank you so much.
Thank you.
Thank you.
Bye.
See you.